This is a Mark 1 Carvera Speedometer, 1964. You just can't buy them anymore. So a few years ago, the odometer stopped working, and I've seen this happen before. Someone greased the wheels, the grease got hard, and that creates enough resistance to make them stop turning. Although, I'm pretty sure mine don't have any grease. And I'm sure, because it was me who rebuilt the Speedo, back then when I restored the car. So I'm kind of familiar with how it works and what can make it fail. Anyway, it should be a simple fix. But that's the thing with simple fixes. They're the ones I tend to drag and neglect the most. It's like they have a way of never becoming urgent. But this year's inspection is coming up, and I've run out of excuses, so... Oh, shit. Alright, let me try to paint a picture for you, give you a rough idea of the problem. This thing here, the pole, tries to pull this gear, but when it gets to some of these teeth, it slips. Now the teeth didn't look too bad, so I went ahead and took everything apart. As far as I could tell though, nothing seemed wrong there. But I did notice a little bit over on the pole, so I tried a different one. And just like that, the problem was fixed. Or was it? The next thing I did was set the same mileage it had before, so I had to take it apart again. Then I reassembled everything with a better pole and made a quick test before putting it back into the case. Only this time, it didn't work. It took me a while to figure it out, and I could only see what the problem was under the microscope. There's wear, sure, but I think there's more than that. It looks like the gear was made with a slight offset, like there's more meat on this side. I know I can bend this spring to improve the engagement between the pole and the gear, squeeze a little bit more life out of it, but I don't think I want a temporary fix. I want to replace the gear. But here comes the problem. Where do you find another one of these gears? I don't know if you noticed, the 800. This is the TPK. It means turns per kilometer. If this was in miles, it would be TPM, turns per mile. It's the exact number of turns the cable has to make to register a mile. So that's the original calibration for this Speedo. 20 teeth times 40 teeth. 800. But why the need to calibrate anything? Because the factory supplied cars with different tires and gearbox ratios. Final drives. Now I'll spare you the math, but I do need to make this clear. Different tires, different final drive ratios, and different countries using different measurement systems were supplied different Speedos with different calibrations. The calibration ensures the driver sees accurate numbers despite the differences I just mentioned. Mileage and speed. Although speed is a little bit different, but we'll talk about it later. But the calibration actually starts in the gearbox, which is where the cable gets its drive. It fits into a worm gear, usually called the Speedo pinion drive, which meshes with a worm driven directly by the gearbox main shaft. Now, gears being gears, they couldn't make this bridge without changing the ratio. So that's why the calibration starts here. You can change them, and you probably should, if for instance you change the final drive. In theory, you can even change these gears to account for a change of tires, but in reality, that's just not practical. Now don't worry, I'm not changing these gears. I'm not pulling the engine out. Not today. So why does this matter? Well, now that you know about this calibration thing, you understand why I can't just go ahead and replace this gear with any other random gear. It needs to be a yellow gear. 40 teeth, that's what I need. I've been going through my stuff for a while now, like a maniac, and I could swear I had a replacement. It's gotta be in here, I just don't know where. This is all early stuff, 5 and 6 digits, all with metal gears. And metal gears are different, they won't work. These are all from the same period as mine, but from other models. All with plastic gears, but none of them is 800. And this one is actually 800 TPK, but I have two problems with it. First, it's not mine. Second, it's the earlier version of my speedometer and I wasn't sure, but I checked and it still has a metal gear, so that won't work. And then I found this one, which is yellow and has the 40 teeth I was looking for. I really thought this was the one until I actually tried it. And man, I've been so obsessed with these, I thought I was going crazy for a while. Can you believe it? All the teeth in this gear are facing the wrong way. No man, you're not crazy. You just didn't know about that production change. Right, so at some point they moved the gear outside the frame, out of the drum cluster. And I get it, it makes sense. Makes it a lot easier to service. I think this happened in '67, when the Mark II replaced the Mark I. There was a revision at that time that most people associate with the face. But just like in '64, the major change was actually mechanical. Now moving the gear outside of the frame required redesigning the anti-reverse mechanism, which is basically this plastic thing, and a spring. I don't know if you can tell, but there's really tiny teeth there. And the same on the gear. It's a very basic design, but it's enough to allow movement one way only. But that only works if the white disc is static. That's what these two locating pins are for. It fits onto the frame, like this. Now on the new version, this part had to be moved together with the gear, but to keep it locked on the frame, they had to flip it. And with that, the only way the gear was going to work was if they flipped it too. And that's why the teeth changed direction. Or at least, that's how I'm reading this whole thing. So what does this all mean? Well, this gear is useless, and I'm still empty-handed. So why don't I just buy another Speedo? Because they're expensive. And that's if you can even find one, let alone with the correct gear inside and in good shape. As you can probably guess by now, these are kinda rare. They were only made for a short period of time, and that was 60 years ago. We can still find survivors, but the problem is, you never know if someone's messed with internals. And that's why it makes no sense to pay the price. So this went on until time was running out and I had to do something. I had to make a decision. Just between you and me, I went and got the car good for another year using a different mechanism. Same mileage, just a different unit. No one will ever know. Hey man. In the meantime, I asked around and sure enough, no one had a yellow gear facing west calling my name. Alright. So I guess there's only one option left. Just leave it like that. After all, it's what everybody does. Who cares if the speedo counts wrong? So yeah, what am I supposed to do? You're gonna make a new gear. It would be silly if I didn't try it. 3D printed in fine detail. It almost worked, but it didn't print the side teeth. There's not enough resolution. I believe these were originally made with a mold. This should be the injection point. And I thought of making one, but I'd like to try machining the actual gear first, before the mold. So I printed a bigger version, so you and I can see better. There are 48 teeth on this face, at what I assume to be a 45-degree angle, but only on one side. These are 0.2 millimeters high, 10 thou if your speedo reads miles. That's really the biggest challenge here. Also, on the original gear, they go all the way to the edge, so I had to create this pocket for tool clearance. And it looks big enough here, but it's 0.4 millimeters on the final gear. This can be done on the mill with a rotary table, or maybe even on the lathe with a little trepanning tool. The teeth on the outside are relatively easy, it's just a matter of offsetting the dividing head. But then we have the center, and that's where things get tricky again. I can only think of using a file, but the hole is 4mm. Can we even get files this small? Anyway, I was trying to get a really good macro shot of the side teeth, and I realized I just can't see them. How am I supposed to machine something I can see? So these and the center are two deal breakers for me. But you're not gonna believe what happened next. Makera, the company bringing CNCs to our desks, reached out and asked,
"Hey, do you have anything that needs machining? Something your manual machines can handle."
It's like they were reading my mind. So I said, okay, can I make this gear with it? They said yes, so I said yes. And that's how I met my Carvera AIR. And OMG, it's a CNC. I was terrified because on the inside, I'm just a grumpy old man with a bit of touchscreen syndrome. And playing with CNCs? I mean, how do you program the thing? Do you need to learn G-code? How about locating the part? And feeling the cut? Wait, let's go back. How do you change the tools? And make an end mill go round in a swirl? But above all, how do you make sure you don't crash the machine the first time you touch it? This was all a bit uncomfortable in my head, but without this experience, I would have never been able to make it. So thanks to Makera for providing the machine. Now, needless to say, this was my first experience with CNC, and I don't know, it wasn't that bad. But saying it wasn't that bad doesn't mean it went perfect on the first try. I ended up scrapping the part. Somehow I forgot to turn the OD, and guess what? The L-ring extrusion isn't perfectly round, or on size. So when I machined the other side, the centers didn't match. But that's okay, I also didn't like the burrs on the side teeth, so that was the perfect excuse to try something different. Now, I'm not used to machining plastics, and I thought one less cutting edge would help. So after a few minutes on the D-bit grinder, I had a single lip cutter for the next try. Slight problem. To machine the teeth around the gear, I need to mount it through the center. And you know, the center isn't exactly round. Yeah, didn't see this one coming. You know how everything today is run by electronics? Yeah, back in the day, everything was much more mechanical. This type of speedometer can look intimidating, but it's actually simple once you get familiar with it. It's pretty cool. Everything's driven by a single cable. You'll see a few wires when this goes back in the car, but those are just for the lighting. So the cable goes from the gearbox to the speedometer, as we've seen before. Inside the unit, it drives two separate systems, the odometer and the speedometer. But while the odometer is gear-driven, the speedometer is driven by a magnet. Yes, a magnet. Just so you know, both systems need fixing in my speedometer. So let's start with the odometer. The cable drives this worm screw, which in turn drives this worm gear. This is what usually breaks, and mine was no exception. It was broken when I first repaired it years ago. But what's interesting about these is that they're the only parts that change between metric and imperial. 20 teeth for the metric gear, 32 for the imperial. The worm screws are different too, but since both have the same number of starts, which is 1, mechanically they are the same. Now if you divide 32 by 20, you get 1.6. And if you Google the conversion from a mile to a kilometer, guess what number comes up? Yup, 1.6. So these gears are basically what converts the unit from metric to imperial. Everything else is the same. So far so good? Alright, see these offset pins on the back? They're not on the center line, so as the gear spins, they act like tiny cranks for the pole. That's what makes it move back and forth. Side note, it's very important to have good tension on the spring, otherwise the pole will either clash against the magnet or float and miss the teeth. But assuming the tension is right, it pulls our favorite gear, which has this key in the center and locks into this V-groove on the shaft. Then we have this plate, which is keyed the same way. So as the gear turns, the shaft and the plate turn with it, 1:1 ratio. What also turns with it is the first digit wheel. So let's talk about the digit wheels. They're basically just internal gears in these guys, with 2 different sides. While on the first side there's teeth all around, on the second there's just a single tooth. That tooth, coupled with these intermediate gears, is the trigger that drives the next one over after 10 full turns. And this is what it looks like in operation. You know what? It was hidden in plain sight. I already know how to hold the gear. Ta-da! This is it! So this guy takes the original shaft, then the gear goes in the middle. You really need shoulders on each side, because the gear is so thin. And these screws just make sure this doesn't go anywhere. Action! You were seeing it coming, weren't you? My first and last try. The machine only came with 1 engraving bit, so that's it, no more playing. But hey, it's not too bad, the gear actually looks very good. What do you think, shall we try it? I don't know how many times I've had this apart for the video, but it was definitely more than 20. And I'm always worried I'll break this hairspring. Either right now or on the next one. Because if I break it, I'm done. No way I'm able to fix it at home. And considering this is the only Speedo I've ever seen with this spring clip, yeah, it's not even funny. And that's the reason why I made this tool. This allows me to pre-assemble the odometer, set whatever mileage I want, and then just take it to the frame as one piece. The shaft slides in, and that's it. No more fiddling with the wheels and the gears near the spring. You need this tool? Check out my Patreon. You know what else I found? Every component has a little extra hole. The digit wheels, the gears, the drive plate. Now watch what happens if you line them all up. Interesting, huh? So this got me thinking, maybe this was the way they did it in the factory? Because right now, I'm only 100 meters away from turning all the wheels at once. And that's gotta be the fastest way to test if the odometer is working. But there's something else. Our gear has a key, right? So assuming they lined up all the holes at the factory, we actually know the original gear orientation. We know exactly how the odometer came out of the factory. And this changes everything, because now we can trace if the wear matches the point where the next wheels roll forward. Think about it, it makes sense. Tripping the next wheel can double or triple the load, easily. Just look at how sharp these are. While these, the ones that took all the beating, are shallower and leaning back. That's wear, from years of pulling more load than the rest of the gear. No wonder the pole was slipping. And the workaround is quite obvious. You don't even need a new gear, just re-index the plate. Make fresh teeth carry the load, and make it a little easier for the worn out ones. Bend the spring a little bit to make sure the pole doesn't slip, and it should last a few more years. Yeah, not so fast. Remember I said I rebuilt the Speedo? Remember on which number it stopped counting? The thing is, at the time, I didn't know about this alignment yet, so I actually rebuilt it with a random orientation. Here's the first clip I took, right after taking the Speedo out of the car. Look at how the worn out teeth are oriented to land on 3. That's on me. That's my doing. Because originally, on the factory build, they were landing on 0, and that's what they did for decades. So I can't get away with reindexing the plate, because that's what I already did, and all it got me was 2000 kilometers. The gear is just too worn out. Luckily I have a new one, which turned out great. And more importantly, it's black. That's a bonus to confuse the next person working on this. It's really nice when you actually connect the dots and make it all make sense. Welcome! This should be fun. Believe it or not, this was the craziest part of the project. And I hope you've seen my toolroom takeover video, cause I'm not really into electronics, okay? But there was a need, and I had to find a way. So, Arduinos. I have a big project coming up where I need to store some data, and I know I'm like 20 years late, but in the research for that project, I found out what these things can actually do. It's not like I'd never heard of them, it's just, I never had a reason to care. But now, oh boy, the projects are piling up. Right, so calibration. More specifically, calibrating the needle. The needle is held by friction alone. There's no key or anything, just a taper at the end of the shaft. That means you can press it on in any orientation, and since we're seeking an accurate speed reading, we'd better get it in the right position. I do know about the alignment dot on the dial, but on a 6-year-old Speedo, forget it. You're much better off taking the car for a drive, checking the speed with the GPS, and then adjusting. Or, did you know you can get it really close on the bench? All based on a simple rule for these speedometers. If the cable spins at a TPM or TPK speed, the needle should point exactly at 60. Why? Basic math. And the other speeds are proportional. So all we need is a driver that spins at a steady, known RPM. And for that we can use a drill. Set it up with a tachometer and calculate which speed should be on the dial. Just a small problem though. Drills aren't usually very steady. And even if they are, the range of speeds you get might not be the most useful. For example, you can calibrate your Speedo perfectly at 120, but you probably drive around 60 most of the time. So I thought that maybe I could have better control of the RPM with an Arduino. I got a Pro Micro, but I had to ditch it almost immediately due to memory problems. Next, I went straight to a Teensy 4. And this was the motor I started with. It's a basic DC motor that has a gearbox in front of it. That should increase the torque at the expense of reducing the speed. We only need to go up to 1500 RPM or so. Then there's the Hall sensor on the back. I tried to create a closed loop system, feeding the RPMs back into the software, but adjusting the PWM signal on the fly was not as easy as I hoped for. It looked promising at first, but fine-tuning it was a nightmare. Another problem I had was still not having enough torque while ramping up to speed. So my next move was to replace the DC motor with a stepper motor. Much higher torque, but it still wasn't enough at higher RPMs. So I added pulleys, and this is the result. It's a calibration tool. But hey, it's not finished, alright? I still want to replace some of the 3D prints with aluminum, now that I have the CNC, and make an ice case. But as you know, nothing's more permanent than a temporary fix, so we'll see. Anyway, I figured I shouldn't show the rat's nest on camera, so this is the middle ground. You can call it an MVP. And I'll be honest with you, I already tried it and I didn't like the sound coming from the mechanism. The rattling and the needle was swinging too much, so I had to split the mechanism. That's something I was really trying to avoid. And the only problem I found was a little bend on the plate that holds the magnet. So I bent it back, cleaned everything really well, and added a little bit of oil. I also changed my mind about the back cover. See the stamp letters around the hole? Now look at this one. This is the original one from my car. I found it while I was looking for the replacement gear. This is the earlier version with the stamp on the side. So I'm fixing this mistake I made and putting the old one back in the car. That's where it belongs. Sometimes things don't have to look new, they have to look right. One more thing, if you've ever rebuilt one of these speedos, you know this rubber grommet is always toasted. It's either falling apart or about to. And although I managed to move the one that was in here to the other case, I have other speeders to rebuild, so I thought it would be good to have some more. I know these are not the same as having the originals, but sometimes you have no other option. In case you need one, I'll leave a link in the description. Now let's go back to the calibration tool. 4 operations available, and we'll start with the odometer check. I guess you probably want to know if the gear works or not. So this is 800 TPK, and I want to run 10 kilometers. Current mileage is... yeah, let me adjust that, make it a round number. The current mileage is optional, it's not actually required, but it's nice to have it, it's like a third check. Let's go. So this option runs the motor for the specified distance. What we're looking for is to compare the before and after registered in the odometer. In terms of calibration, there's not much you can do here. You know it's gear driven and you've seen the math earlier in the video. If you want to change things, change gears. Okay, I'm not gonna make you watch the full 10 minutes. Let's speed this up. Well, I was expecting some error, like not being perfect, but this is what I got. Seems like the odometer is back. I'm really glad the gear works, but there's something that's been bothering me, so let's address the elephant in the room. As you know, I tried the speed calibration before, and besides the noise, there was another problem. The needle was swinging. Also, the needle wasn't even reaching 120, even when its resting position was around 20. That's usually a cable problem, but here, there's no cable. The tool RPMs are steady, and I'll show you that in a second, so the swinging is most likely a sign of a weak magnet. I think that's what's happening here. And I'm kinda hoping that cleaning actually improved things, but I think I know where this is going. I'll probably have to remagnetize it. Now remember the first time you tried, and I mean really tried, to level your lathe? This process is similar. Simple, but please, don't make me do it. Allow me to explain with this other unit. We start by finding the magnet poles. Then we grab a stronger magnet and do the same. Once we know all the poles, we carefully offer our stronger magnet to the speedo, opposite poles. Then slowly move it outwards. We have to do this evenly on both sides and then recheck how the needle behaves. Basically repeat the process until we're happy. And happy here is a strong word. Now if you over-magnetize it and it reaches too high, you have to take it back a little bit. To reduce the strength of the magnet, you need to be spinning it. 500 RPM or so should do it. Then bring the stronger magnet near it and it will demagnetize the speedo magnet a little bit. It will weaken the field. I've never tried it, but I believe this can even be done from the back, so you don't have to take the unit apart every time. It's a delicate dance, and I'm not much of a dancer. So, let's see how bad this really is. Again, 800. And we'll start at 60. Go. All you need to do here is compare the needle with the speed given by the tool. If it doesn't match, we adjust the needle until it does. Actually, we should set it slightly high to avoid speeding tickets, but whatever, it's a Mini. So the way the calibration tool works for the speed is different from the odometer. In the distance test, the code told the motor to run a pre-calculated number of steps at a fixed speed, 60. Once the steps were over, the motor stopped. Speed is different. We don't care about the distance or the total number of steps, we care about frequency. What we need is to maintain a constant RPM. To do that, we calculate the pulse frequency for the target RPM, and then just send it to the motor. We trust it's going to work and that the motor has enough torque to handle it. The code receives no feedback on what's happening with the motor. We could add a sensor to turn this open loop into a closed loop, but according to my testing, it's not really necessary. Yeah, it still bounces a little bit, and the magnet could be stronger, but I don't think it's really worth the risk trying to improve it. For me, it's good to go. Let's get this in the car. First of all, a couple hours a day for 5 days and I had the final gear in my hand. I wasn't expecting that at all. I was never interested in CNC, it's just not exciting for me. But I gotta admit, it's a game changer. To think that you can have something old like my Speedo, not being able to source parts, but then you can make them yourself, just pushing buttons? Good times. Second, what was this all about? It's gotta be some kind of bug in the cam software, right? There was absolutely no reason for the tool to make that movement. Speaking of which, the current cam software is indeed very limited. The machine is fine, from what I've seen it delivers on the promise, but it needs better software. The good news is that MK1 is releasing soon a new cam software. And besides, the machine also supports others like Fusion or VCarve, so you do have options. For me, I still need to explore it a little more. I definitely want to try aluminum, so I'm sure you'll see it in future videos. Just gotta get used to that CNC mindset. I wanted to take the car out for a drive and take some nice shots to finish the video, but as a reminder that a 6-year-old car shouldn't be sitting unused for so long, it didn't get me very far. We started to smell brakes and one of the rear wheels got really hot. In case you don't know, that's very dangerous, in many ways. We checked the handbrake adjustment, but it wasn't that. I still managed to get the car home, and yeah, seems like I have one more thing to fix. It's a C-cylinder. No worries, it's a simple fix. Now, there's something you don't know. The Speedo in this video is very much the reason why I do what I do. I might tell you the story one day, but to me, it gave me the courage to learn what was necessary to restore the car, which then led to other things like machining. Machining led to YouTube, which makes me speak in English. That's so weird. Then 3D printing, CAD, lasers, and now a little bit of cam and electronics. Programming? That's not new. Welding? Hopefully one day. What I want to say is, I've been navigating out of my comfort zone for years, learning new things thanks to this Speedo. It's just a stupid object, but it will always deserve the best I can offer.